morning, good morning, good morning. I hope you know that today is Virgin Galactic Day. Here in New Mexico, it's a big deal. Uh, it's supposed to uh, take off. It was supposed to take off at 6 a.m. They had some weather-related delays, and so now it's taken off at 8:30. So we're excited. I'm very excited. I just wish I could have gone down there. It's so close that I should have gone down there. But in any case, here we are today, and we're gonna put a bee in the pants of Nathan Oakley, Sleeping Warrior, Quantum Eraser, all those guys, and even a few others. We have just started our countdown of the reasons why the Earth cannot be flat. And I expect we'll have many of these. Unlike Eric Dubay, a lot of these will be combined, so we may not have quite 200. So today I want to talk about Nathan Oakley's favorite topic. Oh, he just loves to bring this up. Coriolis. He thinks Coriolis is fake, that it doesn't work. Somehow he seems to love calling things fake. And I have to imagine, that it must be difficult to be Nathan Oakley and believe that everything in the world is fake or a lie. I mean, how do you exist in the world with this kind of attitude toward life? Seems like you just lay in bed and vegetate. But anyway, Coriolis is going to be a big topic. We may take a couple of weeks to cover everything because no matter what anybody says, Coriolis is a big deal. And I'll try to leave you some links. I found some really good explanations, better than I can do. And but let's get into it. Coriolis is caused by the rotation of the Earth. You have to know that the earthquake, or that the equator rotates at a faster rate than, say, New Mexico or England or wherever. It rotates at one rotation per day, which these flat earth guys seem to want to say is irrelevant, but that one rotation per day means that the equator rotates faster than the higher latitudes of both north and south. And so this difference in latitude causes this Coriolis effect from practically everything on the Earth. Today we're going to talk about winds. I like every time I see something that is the wind, it just excites me that it shows the Earth spinning, it shows the speeds, everything that Coriolis gives us, and I hope you get excited about this. Be sure to get your notebook, take some notes so that you can have some lists that you can hit the flat earthers with. So anyway, the first topic is winds. And what you find is the winds change based on Coriolis. One of the videos I'll show you has a diagram of the way Coriolis affects the winds, but you have to look at prevailing winds, not an everyday low or high that causes some rotation. So where I am in New Mexico, in the United States, the prevailing winds are from southwest to northeast, which is exactly what Coriolis predicts. Look on any map that shows Coriolis, and you'll see that the United States, Europe, are all in this band of westerlies. And that's because they come out of the west and go to the northeast. This affects not only just prevailing winds, believe it or not, it affects tornadoes. Tornadoes go from southwest to northeast. In addition to rotating counterclockwise, just like the winds, I just find that amazing when I found out that tornadoes move that southwest to northeast. And, in New York, the upper northeast, you hear of westerlies. What do they call those windstorms that move up the coast? Those windstorms come from southwest to northeast, exactly like Coriolis would say. And so we see all of these winds move from southwest to northeast, just exactly like you would predict using Coriolis. So Coriolis is a real thing. It's a real thing that definitely affects the winds. You'll find the winds south of the equator moving from northwest to southeast, and again, that's prevailing winds. I found it interesting to think about Columbus, Magellan, these guys that did the long range sail. Those guys used those prevailing winds. They were called the trade winds because they're not using the westerlies. They're south of that using the trade winds. They wound up in Caribbean because of the Coriolis, and those sailors, when they got too far south, they ran into what they call the doldrums. Again, you can look up the doldrums on a map, and it was interesting to me that the doldrums are this 5 to 10 degree band that runs all around the equator. That 5 to 10 degree is just dead winds. There are no winds at that location, and it's because the winds are sort of dragged along by the earth. And it's just like if you were in a car, maybe in a convertible, you would find that as you drive, that the winds go with you. So Coriolis affects everything, north of the equator. Opposite of that is everything south of the equator. They have the same bands that we do, the doldrums, the trade winds, westerlies. And so This Coriolis you're going to find with the winds affects everything. Um, Another thing that affects is the winds that travel with the Earth's spin, and these are called the jet stream. There is a jet stream in the northern hemisphere, typically runs from west to east. These are very high speed, generally 200 to 300 miles per hour, running from west to east. In the southern hemisphere, there's also a jet stream, and this jet stream runs from west to east, which seems, you might think it's contradictory, but it's following the Earth's rotation. It's being basically dragged along by the rotation. Its energy comes from the rotation. When you talk to the flat earthers, ask them where the energy comes from for for any winds that they have on the flat earth. Without that rotation, if the earth is still and motionless, there would be no winds, because where would they get the energy to make that trip around the earth? And the last thing I wanted to tell you today about winds is that if the earth were flat, that any wind would come from the North Pole toward the equator, and then from the South Pole to the equator. The reason for that is you think about the equator, based on their sun rotation. The equator is warmer, gets more heat. We all know that hot air rises, so at the equator the wind would rise. This would cause the polar air at the poles to rush in to fill the gap left by the rising warm winds or warm air, and this causes a rotation effect. The warm air rising, moving to the north, winds at the north sinking and moving toward the equator. That type of wind does happen occasionally on the spinning Earth. It's called a Hadley cell. You can look that up, Hadley cell, on weather channels, and they will tell you. I've looked at 4 or 5 of those. They all tell you if the Earth were flat and motionless, that's the wind you would get. So we know that doesn't happen. Any of you that have prevailing winds from the north to the south or south to the north, you need to let me know about that. Be sure to take notes and keep yourself up to date with these scientific principles, and we'll see you on the flip side.